In this class, we're going to consider the idea of infinity. So infinity is a concept that comes up in mathematics a lot, mainly because we're dealing with numbers often, and numbers, carry on indefinitely. So if you imagine a number line where 0 is sort of in the middle, the starting point, and if you start to generate the positive counting numbers, so like 1, 2, so the sort of natural numbers, or positive integers are called. So if we keep going that way, then we start to get some very big numbers, but it doesn't matter how big that number gets, you can just make it bigger. So that is kind of within the idea of infinity. You can always get bigger and bigger and bigger. So infinity is not a number. We often conceptualize it as a number. You get to a certain point, and if it's big enough, then it's infinity. But even if you got to that point, there's infinity beyond that as well. So basically, we have to make sure that we are thinking of infinity as an idea rather than a number. So this would carry on, and we can kind of say maybe that it approaches infinity. So it carries on towards infinity, whatever we mean by that. And if we're going in the positive direction, you might even say that this is tending towards positive infinity. If you went the other way, so if you're starting to build up some numbers on the negative side of 0, just getting smaller and smaller, then eventually this would get like really, really small, and you could say that that's tending towards negative infinity. So even just by that quick conceptualization, we've already decided that we've got two types of infinity. There's positive infinity over here, and there's negative infinity over here. So that kind of already dispels, in some ways, the idea of infinity being like this one thing. But it gets more nuanced than that as well, because if we were to consider, for example, some of the numbers in between these numbers. So let's say that we redrew our number line, but instead of going straight to the counting numbers, we're going to include the rational numbers, so the fractional numbers. And just to even take some fairly simple fractional numbers, let's say 1/2, and then 1/3, and then 1/4. I've actually got that the wrong way around, haven't I? Because 1/4 should really be there, and then 1/3, and then 1/2. So the numbers are getting bigger as we're going that way. But I've just selected some numbers. We don't need all of the numbers. In this case, though, with these rational numbers, so eventually this would start to approach the number 1. So let's say that we put 1 like here, and then you've got a bunch of these rational numbers, and then you've got the number 2, for example. So you've got like numbers that are in this form, fractions, between each of these numbers. So that must mean that if you carried on with this forever and forever and forever, you're also going to have infinitely many of these numbers, but it must be like a bigger version of infinity than this version, because this guy is just all the whole numbers, this guy's all the whole numbers, but also all the numbers in between the whole numbers. So the way that we term that is an order of infinity. So we say that this has got a certain order of infinity, and this guy here has got a different order of infinity. So you don't need to worry too much about like how to measure those orders of infinity. You just need to know that there's basically different types of infinity out there. Again, because we're conceptualizing it as an idea rather than being like a number value in its own right. So I don't want to say much more about infinity. It's an interesting concept that comes back in so many areas of mathematics. But one thing I will say is that sometimes you might see a kind of a way of thinking about infinity as being, if you take some number, let's just call it a, and if you divide or try to divide that number by 0. Now, if you try and do this on your calculator, you're just going to get a big error message, because we don't allow division by 0. Because if you think about what it means to divide, say I had 6 divided by 2, so the answer to that is 3. Well, why is it 3? It's 3 because you need 3 2's to go into 6. So I add 2 and 2 again and 2 again, so I've got this 3 times, and that gives me the 6. So it's how many times a number goes into the other number. So how many zeros go into the number a, regardless of what the number a is? Well, if you just keep adding up all those zeros in the way that I added up all those 2's, you can just keep adding them up forever and forever, and you'll still never even get to a. So you're going to have infinitely many of these. So Sometimes people talk about infinity that way, like if you divide by 0, that's kind of an infinity in a way because you get infinitely many of those into that. But you would never reach A, so it's maybe not a great definition, but just wanted to put that out there because sometimes you'll see people talking about infinity in that way. So the main takeaways from this class, which is really just an overview of working with infinity. There's no technique to learn here. This is background knowledge about number types and number systems and the concepts that they bring up. The key points are just that infinity is an idea rather than a numerical value, and then you get different orders of infinity, which I've demonstrated by this very simple example. So nothing to practice there, you'll be glad to know, just an idea to put out there, and hopefully that makes sense.